The sheet of sea ice covering the north of our planet is constantly shifting with wind and ocean currents, and freezing and melting with the changing seasons. It's mesmerizing to watch several months' worth of ice flow data compressed into a few seconds. But it's not just the surface area of the ice that changes, its thickness changes too. A University of Washington calculation of Arctic sea ice volume shows how dramatically the total amount of ice changes from year to year to year. Here we see thin Arctic sea ice of about 1 or 2 meters represented by the edges of this idealized pile, and thicker ice of 3 or 4 or 5 meters in the middle. It's interesting to watch these seasonal changes, but climate researchers focus more on the overall trend. Let's look at the change in area of sea ice cover at the peak of the melt season, when sea ice is at its smallest. We see it has shrunk considerably in the last 35 years. Now, let's lay thickness data on top of that, and we get a sense of how much ice volume has also decreased.
It's really a very different ice pack than what we used to see in the 1970s and 1980s when we first started tracking it with satellites. It's an ice pack that is much thinner than it used to be. It's covering much less area, especially during summer than it used to. It's an ice pack that's more broken up. It's moving around more with the winds.
The thickness determines, in large part, how long it's going to stay around. So is it going to survive the summer? So sea ice affects the exchange of radiation, heat, energy, momentum between the ocean and the atmosphere. So sea ice is a very good insulator between the ocean and atmosphere. So if there was no sea ice on the ocean, the atmosphere around the Arctic would be much warmer. And this would change the entire global circulation.
Climate models predict that in a matter of decades, we will see a relatively ice-free Arctic Ocean during the summer months.
But the ice will still grow back in the wintertime. The sun goes down in the Arctic, it's still going to get cold, you're still going to grow ice. But it's going to be a very different type of ice cover from what we've seen in the past.